Can you hear me now?
Yes.
Hello everyone, and thanks for joining. My name is Stefano Rago, and I'm currently working with Blacklane. Although a good part of the work that I'm presenting today was actually developed at my previous job at Agile Software. A brief agenda. What we'll be covering today is basically the importance of user interfaces and UX, a couple of definitions, and why it's challenging to implement proper user interfaces from a cosmetic point of view, how this impacts user experience, and I will present an approach which is basically based on test-driven development and continuous integration and delivery. So let's start with a couple of definitions which is helpful for the scope, at least, of this presentation, for the purpose of the presentation. There are many definitions out there, but I found the following two which are particularly fitting for this. And according to these definitions, user experience is everything that encompasses all interactions between users and a company and brand. So for example, in the case of Blacklane, user experience is everything that happens from the moment a user decides to book a ride, uses our mobile applications or website to book this ride, the time for the ride is coming, so the user meets the driver, takes the actual ride, comes to the destination. All of these are touch points between the customer and the company, so this is all part of user experience. Whereas UI is everything that is visual of a brand and that is transferred to the user. So, and it's also responsible for transferring the brand's strength to the final customer. And it has to do it, or the idea is to do it in a way that enhances the experience. So these two concepts are quite coupled together. You can have a website or an application that it's good on user experience scope, so it's easy to use, it's intuitive, but it's ugly and user design is poor. On the other hand, you can have very good user design, nice, good-looking interfaces, but at the same time, your system is difficult to navigate, it's difficult to use. For example, in the case of a website, it's not easy to find the information you're looking for. So it's clear that these two concepts have to go hand in hand, and they deserve equally important focus. The industry is starting to recognize the importance of these disciplines in the recent years, and I've been collecting some numbers. In particular, there is a huge number of people claiming that they're not going to return to your systems, your website or web applications, or applications in general for that matter, if they don't have good experience. This is probably intuitive and obvious, but still it's interesting to see this being backed up by actual studies. And it's a huge number of people claiming that. Also, credibility of your brand is highly affected. A lot of people are claiming that if they see poor design or poorly implemented design, it's going to affect your brand's credibility. Another important point is conversion rates. A huge number of people will convert to your business if you do experience and design well. It's quite difficult to estimate return on investment on these disciplines, but it's possible, and companies are starting to find ways to understand how much is coming back from their investments in these disciplines. And for example, a company like IBM came up with this interesting rule of thumb stating that for every $1 that you put in researching UX and UI, you get about $100 in return, so not bad at all. Why do we still experience a lot of defects in user interfaces, although the industry recognizes the importance of focusing on these aspects? We will see that soon. I collected some samples. I'm not trying to be judgmental here or blaming these particular examples that I'm quoting. It's just to have a common understanding of particular issues that we are talking about. But this can happen to anyone. I've been developing web applications and websites myself, and what we're going to see happen to myself a lot of times. This is an example from LinkedIn, for example. This confirmation banner is clearly misaligned vertically. Another example, because not only web or browser-based applications are suffering from this. This is an example of a mobile app, for example. Another example of a brand which puts a lot of emphasis on these aspects, like Apple, can still fail in this regard. And I can relate to this user's comment saying that for Apple standards, which put so much focus on this stuff, this looks like 3 different bugs. Yet again, another example, this is pretty obvious. The layout here is Breaking Bad. Also, desktop applications are not free from such defects. So if you do have desktop applications, you probably want to make sure that stuff like this is not happening. I thought that this particular example is quite relevant and interesting because it shows, I think it shows how the people involved in implementing this or testing it, this component, didn't have internationalization into account, for example. And German is notorious for being quite long, for having quite long words, but it's not the only language. I recently found out that Finnish is as bad, if not worse, for this matter. Another big brand going out there with an obvious flaw in their user interface. Here is not clear what's going to happen when you click this button on the top right, if it's going to go to the menu, some kind of menu, or skip to the next song or album, or go to the now playing section. And this is even more confusing, where the person staring at the screen is not sure whether or not they're going to wake up at this horrible time in the morning. So, yeah, can be confusing. So, yeah, yet another example. In this case, the user got so much accustomed to this wrong way of rendering the interface, is wondering if this is ever going to be fixed. But yeah, again, this is not to judge these particular brands, it's just examples, and it can happen. It happened to myself a lot. Why does this happen? Because there are many challenges, and probably the number one is the amount of devices that we have. So we have laptops, fixed workstations, phones, smartphones, tablets, something that doesn't even appear here, like smartwatches or projectors. So you can see that the size of the screens where your user interfaces are going to be rendered and delivered can vary, can change a lot, from a few centimeters to a few meters of size. So you have to probably want to be ready, depending on the type of systems that you are delivering. You want to be ready for all of that. There's also, on top of that, complicating the situation, the amount of operating systems and browsers. And the same browsers can sometimes render differently your user interfaces depending on the operating system where they're running. Even if you focus on a specific browser, on a specific operating system, there's still to take into account that people will use your window, will resize your windows where your systems are being displayed, so you have to take into account responsiveness, for example. And internationalization, as we've seen, can break easily your layout. But in general, dynamic content can be a problem. Take, for example, a blog, where you design your blog page to show some text and some images, but the editors can easily embed media, like, for example, tweets or YouTube videos, slides from a conference and stuff like that. And you want to make sure that all of that looks good as intended. You have a way of delivering that in the best possible way. So I came up with a simple example of a website that's only 10 pages, not too much. You want to, for example, support only three browsers. You cannot go around without supporting at least 2 mobile devices. So you have 2 orientations, landscape and portrait, 3 responsive breakpoints, which is not that much. And even in this simple scenario, you will end up having to deal with 360 different possibilities of how your user interface is being rendered. Again, this is a quite simple situation. In reality, you will have probably more complex situations and numbers that are a lot higher than that. So you can see how Manual testing, although it has some advantages over automated tests, like the flexibility and the capability of spotting false positives more easily, it's simply error-prone and tedious, and there's been studies proving that the human brain is very bad at detecting visual differences. So manual testing in this regard is not the best approach. Also, it's simply not feasible to take into account all the possibilities, even in the simple example we saw before. So what generally ends up happening is that people will run QA stages of manual testing for visual interfaces only in particular times of the development life cycle, probably before a release, because it takes so much time. To run this test manually, and it's quite tedious. The costs are very high, and the most important point is that it introduces a very long delay in your delivery pipeline. You want to reduce as much as possible the time from when you have something that is working to the time it's actually being delivered to your customer. And having manual tests introducing this delay is the last thing we want to have. For this, automated testing helps a lot. The fact that it's automated means you can easily find a spot in your continuous integration and delivery pipelines. You can give a very nice and quick feedback to the developers. So the most important point that I've been trying to make so far is from a business perspective, that your brand benefits from strength in delivering your user interfaces in an impeccable way. But this is another important takeaway, I believe. So the fact that the users will benefit from a good-looking user interface, but also that the developers are benefiting from the safety net that these tests are basically providing. The fact that they can easily refactor code and can immediately assess the impact of the changes that they're making to this code base. It's a great benefit to developers. Imagine, for example, when you find an issue like the ones we've seen, when they are already in production, after the changes that caused these issues have been already probably partially overwritten, or the code has been merged, there have been patches, the history of your code has changed. So it's quite difficult to trace back the reasons for these failures. Whereas if you know immediately when you are committing your changes that you are causing a breaking layout or even more serious problems, it's a lot cheaper to find that out and fix it, amend your changes, reverse them, or find a way that your changes don't break and don't cause unexpected behavior in your user interface. The fact that they are automated also means that you can target different systems, so not only your local development server, for example, but you can target the same tests with the same logic on your production system, for example, if you want to do some kind of continuous monitoring, which might make sense because the deployment pipeline can introduce, for example, a difference in the way your user interface are actually rendered in the end. Of course, all of this comes with some drawbacks. It's not only positive stuff, there's also the maintenance that is needed to run your tests. Not only the test code itself, but also the infrastructure that is required to have all of this set up running. And of course, the time that is required to run these tests is something that you have to take into account. But there is a huge support from different tools to run automated testing for visual interfaces. Some of them vary depending on the approach that they take. One, which is the most common, is taking screenshots that serve as a reference and comparing how your user interface changes compared to the screenshot. If something important changes, then your test will fail. Another approach is based on relative location of elements. So you can specify, for example, this particular button should be 10 pixels from the left or from the top, or a label, what color should that be, and so on. There's support for different languages, so if your technology stack is based on a particular language, you will probably find a tool that integrates with not only that language, but also the testing framework that you are using. For example, there are tools that integrate well with RSpec or Nose if you're doing Python, Node.js stuff. and also that they're able to report the results of the test in a way that they can easily be parsed and integrated in continuous integration. There's also a lot of support for smart detection of issues. So a lot of times with pixel by pixel comparison, what can happen is that you run into false positives. There are smart algorithms that allow you to ignore certain things that you know are not relevant for the end user. So if it's something that is not perceivable, you probably don't want your tests to fail, and these algorithms help you with that. Some tools even offer support for determining the coverage of your visual interfaces code, so you can understand if some particular areas of your user interface code is not well tested, and you can improve on that. Another thing that's highly helpful is having a way during your code reviews to understand how these code changes are impacting your user interfaces. Without that, it's probably difficult to understand if you should accept some changes or not, and these tools help you with that. And of course, a lot of this stuff is offered as a service, so if you have budget for that, you can rely on third-party providers that solve a lot of problems for you, from setting up the infrastructure to actually maintaining up to date all the components involved. Our approach is based on a particular set of the solutions that are available, but it's not mandatory to use. I'm not advocating a particular solution here. It's just the important thing is to highlight for me the concepts and the approach. But if you use a different stack, then you will probably find different solutions that fit your particular need. As everything in software, we have to understand what's the best solution, because there's no absolute winner, I think. There's always the right solution for our use case. And for our use case, this is what we ended up with. So it's basically targeting web applications and websites, as I said before. So it's all basically based on browser testing, Selenium, as we will see. It's based on screenshots, and as I mentioned at the beginning of the talk, the approach is based on TDD, because you can do that also with user interface testing. The idea is that you start with a test, which in this case will probably be a screenshot, and until you have your user interface conforming to that, your test will be failing. You will keep making changes until you have no differences between what your designer gave you and the actual implementation. And at the end, you also have a working test that is working as a regression kind of check. Outside in is also something that comes from TDD approach. So in the case of websites, for example, you start with the outermost part of your user interface, for example, a web page, and then you break it down into components and go all the way down until a unit, which in this case could be, for example, a button or a label. And once you have all those tests passing for the units, you go to the outer layers and fix all the rest of the tests until you have your whole page implemented and you have a bunch of tests testing the different parts and as a whole. We've been using Python a lot and PyTest as a test framework. So there are tools that integrate pretty well with this ecosystem, and the solution for abstracting our visual tests and for running and wrapping the Selenium logic is called Needle. It's a Python-based library. It offers you a nice API to control which kind of browsers you want to use, which screen sizes, and so on. And as I mentioned also, we're basing the whole setup on a Selenium grid, which is used both during development and during continuous integration. So in this way, we have a single reference for our tests. All our tests are running using always the same set of browsers and platforms. So this is a more schematic view on the approach. The first thing is the interaction between the developer and the Selenium grid. So what happens here is that the developer is implementing or making changes that he received from the designer. He's using the Selenium grid. Once the tests are passing and the baseline is created, the changes will be pushed to the continuous integration server. In our case, it's a GitLab server, which is also running continuous integration and deployment and acting as a Git repository. What will happen as soon as the changes are pushed, there is a new runner that is being spawned, and it's responsible of running the whole test suite. And it will use the same Selenium grid that's being used in development. If everything goes fine, we set up the pipeline in a way that these changes will be automatically delivered to the customer. So you can see that here, if there is something that breaks the layout or introduces unintended changes, step number 5 will not execute. But if everything goes fine, we immediately delivered our value, if we can call it that. I'd like to show you in practice how this setup works. So for the demo, I've been preparing a very similar setup as we saw in the approach part. And basically all of these blue boxes are containers running on my machine. So I will show you the Docker Compose file that I'm using for the setup. It's a GitLab server using the default GitLab image. Also, we have a GitLab runner, also in this case, official GitLab Docker image. They're linked together with the Selenium grid. Selenium grid has everything it needs, so the hub and the node, even a browser, so it's a self-contained exemplary setup. And it's listening on a VNC port, so we will be observing in real time what's happening. Last but not least, there is a simulation of a production server which is running a combination of Nginx, micro WSGI, and Flask. The demo is based on a Flask-based, very simple web application. Actually, the website is quite simple. And this is the pipeline that I was talking about. So you can see there is a bunch of steps, the classical ones. These, in this case, are not doing anything. It's just useful to see the context where the visual testing step, this one on the right, is located. In general, if anything here fails, you probably don't want to spend time. You want to end the feedback loop immediately and fix your logical problems or whatever error it's coming even before visual testing. But if everything goes fine, then you can see that changes will be automatically deployed to production. The code for this pipeline is here. You can see that I faked all the initial steps because they're not relevant for this demo, but what's interesting is the visual test step. And basically what's happening here, we are running a PyTest, specifying what kind of browser we want to use. So you can easily parameterize this, for example, to support your different browsers, the browsers that you decide to support. The IP of the Selenium grid that's going to be used, and the location of your tests, which in this case, I just created a couple of tests. One, it's kind of end-to-end test. Can you read from the back? Yeah. It's kind of end-to-end test, which is basically testing the whole page at once. And there is another test, which is kind of component or a unit test even, which is for the navigation bar only. And it's going to make sure that this part here looks good as intended per se. So let's assume, for example, that our designer is coming up with a new change for this navigation bar, and they want these gray buttons to become blue, as in here. Since we have already a test, proceeding in typical test-driven approach, the first thing that we do is we update our baseline in order to have our failing test, which will then drive our implementation of these changes. So I'm updating the baseline and running the particular test that is affected. So let me spin my VNC client. It's actually already running. So we start the test and observe. In this case, I haven't made any changes yet because I want the failure of the test described to me what's needed next. So I'm moving on, doing baby steps here. The test failed as we expected, and it's telling us that there are 1,347 pixels, something that is not really tangible. But the nice thing about Needle is that it gives us a visual interpretation of this failure. So I can look at this diff. I don't know if you can see that. It's basically highlighting all the pixels that are differing and that are causing our failure. So what I can do now is go on and implement the necessary changes. And I'm doing that in a deliberately aggressive way, so greedy kind of expression that normally nobody would use, but it's helpful to prove my point. Rerun the test. Let's observe what's going on. So the test is contacting the Selenium grid. The Selenium grid is starting a browser. The browser is targeting the test server, which is running on my machine, my development environment, so to speak. And this time around, as we hoped for, our test passed. That means that our changes are implementing the requirement from the designer. So I can push these changes to continuous integration to our Git repository, giving a nice commit message. And as we said before, as soon as I push these changes, there's going to be a new pipeline running and will execute all the steps involved. In this case, we can see that the production server so far hasn't been affected. The changes that we pushed are not even considered for deployment. That's until the whole pipeline is executing. So now the visual tests are running. Let's observe them in real time. In the meantime, I'll shortly discuss the setup for the deployment. The deployment here is quite simple. Everything is using Docker, so what you will do here for the deployment is probably create a new image containing your changes. For the sake of this demo, what I did is just triggering a pull on the production server. So it's quite easy, but yeah, serves the purpose of showing the flow. So some of you may already have spotted a problem here. Basically what's happening is, the test probably failed. The process is still running, but the idea is that we didn't run all of the tests in development. We only ran the one which we thought was relevant. But what really happened is we introduced some changes that we didn't intend to do. As you can see here, the elements that are affected are not only these ones, and we can see it on the result of the test suite. So every time the test fails in our continuous integration system, we have a way to publish all the diff files that we've seen before. So you can see that I not only changed the navigation bar, but I also introduced changes that I didn't want to do. And this is basically where the added value of this approach is. So I have now the possibility to understand that I'm doing something wrong, and right now I have the time to fix that. If I didn't do that, these changes would probably be deployed, and with time it would be quite difficult to understand what was the reason for this. So let's actually amend this problem and create a rule which is more sensible. Basically here I'm restricting the scope of this rule to only the navigation bar. And this time, because I know that I am affecting several parts of the system, I want to run all of the tests without letting behind anything. The first one, I want to make sure that the intended changes for what I want to change are still there. And the second one is to make sure that there's no collateral effect. The test, as I expected, is still failing, and the reason is that I haven't updated my baseline for the whole page. So what I can do now is rerun the tests in a baseline generating mode. So there is this option called needle save baseline, which is basically updating the baseline to match the current status of the UI. This is a particularly delicate step because if you are overriding stuff, you have the risk of introducing changes that you don't want. So when you do this part, always make sure that you are creating a new baseline that really matches what you want it to be. Now the tests are all passing. What I'm pushing now to continuous integration is both the fix for that kind of bug that I was introducing and the new baseline for the whole page. This time around, I expect that all the tests are passing, and if that happens, then I expect also these changes to be automatically delivered here. So far, there hasn't been any change here to our production server, but as soon as the new pipeline is finished, I expect these changes to be deployed. So while the pipeline is running, I can already anticipate the conclusions. Basically, this approach has proven really useful and quite valuable for a number of reasons. The fact that we have, as developers, we have our lives a lot easier because it's easy to understand the issues and to understand the reasons for the issues. And also we have more confidence understanding and delivering the brand as intended. So it has a twofold advantage, not only business but also operative kind of advantage for us. Let's see if this pipeline is done. Yeah, the visual tests have passed, and now the only thing that's left is the production deployment. So as I was explaining before, the production deployment is nothing else but a Git pull that you can see here. So at the end of this Git pull, we should see the new style delivered to the end customer. Let's go back to the slides. Some considerations left, just that you have to take into account the duration of these tests. You want to keep it down because as soon as the feedback loop grows too high and becomes too long, it will not be as useful as it can be. There are some maintenance costs, so all this setup of Selenium Grid and GitLab, it's something that puts additional effort on you, but you probably have that partly anyway because of all the rest of your testing that you are already doing. There's also some time required to bring your system under test into the state where you actually want to do the test. So for example, in the case of a mobile app, you need to navigate from a screen to the next, provide some data, or pre-populate your data set. So in order to make it representative and be actually meaningful tests. False positive detection is something that we haven't integrated yet, so it's a kind of future improvement that we want to bring to our approach, and also continuous monitoring. It's something that we haven't yet explored, but we think it could be quite valuable. So overall, it's something that we recommend. You don't have to use the same exact tools, but just the takeaways here are business strength and life easier for developing user interfaces and confidence when delivering them. So that was the end of my talk.